गुड मॉर्निंग स्टूडेंट्स। आज जो हम पढ़ने जा रहे हैं स्टूडेंट वो है सेक्शन 17.2, राइट। इन दिस लेक्चर आई विल टीच यू अबाउट द maximum and minimum, that is the definition of maximum minimum, right? Then definition of maximum point. After that there is one useful result, right? That is again a very important result, right? Then there is a theorem 17.2. Okay, this is very important theorem, right? Then there is a proof. Then there is some other definition, like the definition of interior point, boundary point, exterior point, then the definition of open set and closed set, right? So this is all about the section 17.2, right? So let us start section 17.2. स्टूडेंट्स, डेफिनेशन ऑफ मैक्सिमम पॉइंट और मिनिमम पॉइंट जानने से पहले कुछ आपको बेसिक चीजें पता होनी चाहिए। हो सकता है ये चीज आपको मालूम हो, बट इसको अच्छे ढंग से समझाने के लिए मैं दोबारा से आई विल ट्राई टू रिवाइज इट, राइट। चलिए, वो इंपॉर्टेंट चीजें क्या है, लेट अस सी। इफ आई से a domain of a domain of a function with two variables is x, okay, it means the s should be the subset of R2. Okay, student, right? It means if I say x belongs to s. Now what is s? S is the subset of R2, right? Because the function is given of two variables, right? That means the function is defined for two tuples, okay? Two tuples. Or you can say the function is defined for every ordered pair. Okay, that means x should be of the form that is 2, 3, right? Or it may be 1, 5, 2, 7, right? So that means whenever I say that the function is defined for two variables, right? That means the domain of that function should be the subset of two tuples, okay? That means each of the members of the domain is of the form that is x equal to 2, 3 or x equal to 1, 5 or x, 2, 7, right? So that means if I say y belongs to set S, right? That means y can be 1, 2, right? Similarly, if I say a function is defined or we can say that a function of three variables, it means the domain of the function, let the domain of the function is S, right? Domain of the function S should be the subset of three tuples, right? It means if I say X belongs to set S, this implies all the X are of the form three tuples. That is, X may be 1, 2, 3. X may be 1, 0, -2, right? So all these should be of the form of three tuples, right, student? Similarly, if I say a function of four variables, whose domain is S, whose domain is S, this implies S should be the subset of four tuples, right? So if I say X belongs to S, that means X is of the form 1, 0, -2, 3, right? That means X should be of the form of four tuples, right? If I say Y belongs to S, this implies Y can be of the form 0, -1, 2, -3, right, student? Similarly, if I say a function of n variables, whose domain is S, whose domain is S, that means this S should be the subset of n tuples, right? So if I say X is any member of set S, it means X of the form, that is X can be of the form 1, 2, 0, 3, dot, and this contains n entries. That means this sequence of n real numbers, right? So what I said if I say a function is of two variables whose domain is S, right? And if I say X belongs to S, this implies X can be of the form of two tuples. That is, X can be 2, 3, 1, 5, 2, 7. And each entry that is represent a different, you can say distinct independent variable, right? Right, student? I mean to say that these two can be income, right? And these three can be price, okay? For a particular problem, right? Similarly, this one is income and this 5 is price. Similarly, this 2 is income and this 7 is price. Okay, student? Now the definition of maximum and minimum, right? So in your book, you can see, let f be a function of n variables, right? Whose domain is set S, right? So that means each of the members of the set has n entries in each member of the set S, right? Suppose that C belongs to set S. What does that means? That means if I say a function f defined for, you can say a function f of n variables, right? It means its domain S should be the subset of n tuples, right? That means each of the members of the set S has n entries there in their members. I mean to say, if I say X belongs to set S, that means X is a sequence of n real numbers, right? Just like this, right? It is a sequence of n real numbers. And each term of the sequence represents a different independent variable. That it means these two represent, like, let it be income. These three can be your price, the goods, and this can be the number of labors, okay, and so on, right, student? So if I say a function f of n variables having domain set S should be the subset of n tuples, and X belongs to set S, right? Then if there exists C belongs to set S such that f of X is always greater than or equal to f of C, right? It means C is the minimum point. Here, this X is true for all X belong to set S, right? What it means? It means if there exists a number C, you can say a member C belong to set S such that f of X is greater than or equal to f of C, and it is true for all X belongs to set S, then C is the minimum point, okay? And f of C is called minimum value of the function, right, student? So this is all about the minimum point and the minimum value of the function, right? Now, maximum point and maximum value of the function, right? Suppose f is a function of n variables. F is a function of n variables, right? That means its domain S is the subset of n tuple, right? Now suppose there exists, now suppose there exists a point C belongs to set S such that f of x is always less than equal to f of c for all values of x. It means what? It means the value of the function at point x at point c is always greater than all the values of the function at other points. Then the point C, point C is called maximum point. And f of c is called your maximum value of the function. Right, student? Or we can say f of c is the global maximum. Okay, student? So this is what written here. See, let f be a function of n variables defined over a set S. That means S is a domain, right? In n tuples. Suppose that C equal to, because C belongs to set S, that means C is a sequence of n real numbers that belong to set S. Gives a value to f that is larger than or equal to the values attained by f at all other points. It means what? It means f of c is the largest value, right? F of c is the largest value it gives as compared to all the points of domain, right? So that is why the point C is called maximum point, or you can say global maximum point, right? And f of c is called the maximum value, right? Any problem, student, here? Now there is a result. And what is that? Suppose that f is a function of n variables defined over set S in Rn, and that f of x is less than or equal to f of c for all s in x. So C maximize f over s, then f of x, that is minus of f of x, it is minus of f of x less than or equal to greater than or equal to minus f of c for all x in s. What does that mean? See here. If I say student, if I say C is the global maximum point of a function of n variables. It means what? It means f of x less than or equal to f of c for all x belongs to set S. What is set S? That is domain, right? Then this implies minus f of x is greater than or equal to minus f of c. Okay. Now, suppose, or let us consider g of x equal to minus f of x, right? This implies g of c equal to minus f of c, right? So equation first we can write as g of x is greater than or equal to g of c, right, student? What does that means? It means according to the definition of minimum point of a function, right? According to the definition of minimum point of a function, this c becomes the global minimum point of function g, g of x. So this implies c is a global minimum point global minimum point of g of x. Means in place of g of x I can write minus f of x. Okay, student. This implies g of x is a minimum value. G of c is a minimum value. The function g of c is a minimum value of the function g of x. So this implies minus f of c, because in place of g of c I can write minus f of c from this equation, right? Is a minimum value of the function minus f of x, right? So this is what written here, right? You can read it again. What is written? Suppose that f is a function of n variables defined over a set S in Rn, and that f of x is less than or equal to f of c. That means c is the maximum value of the, c is the maximum point of the function f of x. That means f of c is the maximum value of the given function, right? Then c becomes the minimum point of the function minus f of x, right? It means if c is the maximum point of f of x, then c becomes the minimum point of minus f of x function, right? It means if f of c is the maximum value of the function f of x, then minus f of c becomes the minimum value of the function minus f of x, right? So this is the meaning of this paragraph, right, student? Now